Well, here's a nice review of logarithms. The first, you use the basic definition. Log with a base of w means w is the base, the number on the other side is the exponent. And then it equals the number that was substituted into the log. In order to solve for w, then, we would need to get rid of this fourth power, so we need to use the fourth root. So we take the fourth root of both sides. Usually when you take an even root, like square root or fourth root, you have to put plus or minus. But with logarithms, they can't have negative base. So we only use the positive fourth root. So for fourth root, you can go 3, raise it to the 1/4. That means fourth root. Or you can type the 4 first, and if you've got one of these calculators, you go to math and then down to x root, and then that will take the fourth root also. So it's a 1.316. In order to solve for an exponent, well, that's the whole job of logarithms. So what I would do in this case is take log of both sides, and you can use log base 10 or you can use natural log. I'll use natural log. And then use the rule from logarithms that says this exponent, you can bring it down and multiply right here. So you'd have an n times the log of 3 equals natural log of 8. Well, just like in regular algebra, solving for the variable, if you want to get rid of this, divide both sides by it. So to get rid of this, divide by the natural log of 3, divide by the natural log of 3, and then find out what is the natural log of 8 divided by the natural log of 3. So the natural log of 8, parentheses, divided by the natural log of 3 is a 1.893. And I can even check my answer if I store that. I'll just store it as the letter x. And then I go back to this and substitute it in. 3 raised to my answer should equal 8. Ta-da! So this answer is correct. Alright, continue over here. There's another rule for logarithms that says if you're subtracting two logarithms, then you can, and the bases have to be the same, which they are, then you can rewrite that as one logarithm, base 2, and since we were subtracting, you then actually divide these. The first one divided by the second. And then we're in a situation much like this, where you go take the base, raise it to this side, which is the exponent. So take the base of 2, raise it to the exponent of 3, and that gets rid of the logarithm and leaves us just x plus 2 over x. So we've got x plus 2 over x equals 8, or you could look at it as 8 over 1. And once we have a fraction equals a fraction, you can cross multiply. So in this direction, we would get 8x. And in the other direction, well, it's times 1, so that's just x plus 2. 2 more steps. Subtract x from both sides, so it becomes 7x equals 2. And then divide both sides by 7. X is equal to 2 over 7. One note over here, you can't take the log of a negative. So if this would have been x equals a negative, which it's not, but if it would have been x equals a negative something, then I would have to throw out the answer and say no solution. And then the other rule for logarithms is when it says plus, you do like we did on the other one, change it to one logarithm, so log base 2, but with it being plus, you then multiply these two things. So x squared minus 9 gets multiplied with 1 over x minus 3. And then all of that is inside one giant logarithm. And then one more time, take this base, raise it to that exponent. 2 is raised to the 1. And then this part, we can even start simplifying because x squared minus 9 can be factored as x plus 3 times x minus 3. And then we could even simplify, have these x minus 3's cancel, and it leaves just x plus 3 is equal to 2. And then if you subtract 3 from both sides, it's going to leave 2 minus 3, which is negative 1. Then, are we going to have to throw that away? Well, let's see. If you substitute a negative 1 right here, that's going to be negative 4 for the denominator. That means this is going to become a negative 1/4. No, that's not allowed. So there's no solution to that one.